So, hello guys, and I welcome you all to the first session of the machine learning. So, I hope you find it easy and let us keep it simpler. And in this tutorial, we'll have a look at the linear regression machine learning algorithm, which is simple. It's the easiest algorithm ever. So, it will be easy for you to understand. So, let us start. So, let me take a graph and I have this values of area and price. So what we'll do is we'll plot a graph according to the area and the price like this. So I remember in my PU and in my physics labs. So what we used to do is we used to get the values and we used to mark it on a graph and like we used to get the values like this somewhere and it doesn't used to be in a straight line. So we had to adjust it so that it coincides, all the 3 points coincide. So what we used to do, we used to draw a line and we used to adjust these points. We used to put a circle in a pencil so that these points are like touching the circle. Okay. So we used to adjust this. So, but in the machine learning algorithm, what it will do, so it will automatically create a line. Okay, will automatically create a linear regression line and it will try to reduce the error. So what are the errors? The error between these two. The error, this is called as the error. Okay. So it will select a line in such a way that the error is minimum. Okay. So this is the simple linear regression and the expression for this is you might be knowing y is equal to mx plus c. Y is equal to mx plus c. So y and x are the points and m is the slope. Let me it. Yeah, y is equal to mx. So we will get into our coding part and we'll see how we can achieve it. I'll give you the GitHub repository link. The first thing we'll go to Colab, Google Colab. So this is a Google product. It is a Python compiler and it has a built-in libraries, so you can use this. If you want, you can try to run it in your own PC also, but I suggest you can use it, Google Colab. So this is open source and you can run it, is like faster compared to your PC. You can go here, create on new notebook, or you can give it as open notebook and go to GitHub, and here I will give you the URL. Yeah, just paste the URL over here and we'll directly get my code. Okay, you'll directly get my code. So let us start. Initially, we'll be importing the pandas as PD and NumPy, and also we'll be importing the sklearn library. So what is sklearn library? So sklearn library. So this is used to train your model. Like we have different machine learning algorithms like linear regression, decision trees, random forest, and many other algorithms. So this will have a built-in training, built-in modules where you can it will automatically train the model. We'll have a look at it. We have imported the sklearn library, and we also need a matplot. This is used to plot the points. So while we were visualizing our this one right here, so to visualize this, we need a matplot library, and this will plot all the points. and we will take a data set, the same data set which I showed you over here. This data set, I have taken it over here, and we need to give it in a CSV format. Okay, to create a CSV file, in your left corner you'll have this file icon. Click on this and create new file. Right click and create on new file. Okay, I'll give it as something data.csv. I'll rename it as CSV. Now open it, double click to open it. Okay, initially I'll keep it in a format file dot txt. Here I'll paste the data. Okay, I'll save it. And now let me rename the file to CSV. So what I'm actually doing this is I need to write this data in a CSV format. So what you can do is you can copy this data. You can go to Excel. You can paste it, create a new Excel file. You can paste it over here. Yeah, give you the CSV file. You need to paste it over here, or we'll have a CSV file. We'll need to upload it over here, and then we'll be importing using the pandas library. Here we can see df is a variable which we are taking. Df read CSV. This is used to read the CSV file. We'll write as data, as we have kept it data.csv. Let me run it. So this will give you the values over here. Let me run it. Okay, and I'll create a new code and I'll print df. So what this df will do, control plus enter will run this cell. We close this and df. So this is the data set which we had taken over here. Okay, this is presented in a table format. And now let me try to plot it. So matplotlib, and here I am giving the x label. So this is all not required. Not x label, y label. You can directly come to dot scatter, and here let me show you what is df.area. If I print df, just df, it will give me the full tables, all the two tables. Okay, and if I write df.area, which means it will just print the area table. Okay, it will give me the values which are there in just area. And if I print, we had another table which is a price, and if I write it as price, selling price, and if I give it as price, it will print the values which are there in price table over here, these values. So here what we are doing is, on the x-axis we are giving the area, and we are giving the price here, and here we are giving the color of the, we can remove it, we'll just run, this much is enough. This will give you the plotted values. It will plot the values. Now if I just see, and here if I just visualize, if I draw an imaginary line from here to here, okay, here to here, there are some errors. Okay, these are the errors. Okay, this is the error, and this is the error, and this is the error. So this sklearn library, when we train the model, it will automatically try to reduce as much as possible the error. It will try to draw it in such a way that the errors are minimum. So here you can see the distance. It will calculate all this distance between the points in the line. It will try to minimize the error. And let me come back to my plot, to my code. Here, what we are doing is, as we had separated these two things, we have df.price and we have df.area, right? What I will do, I will take it in a separate variable. You can do it like this, or I can write it as x is equal to df.area. Area. Okay. And I'll take y is equal to df.price. Let me visualize these two. I'll print x and let me print y also. So yeah, it is good to go. And here, creating a linear regression object. So here, as we imported over here from sklearn, we are importing a linear model, linear regression model, machine learning model. Okay, linear model, linear regression. We are taking, and I need to write regression.fit. Here I'll give it as x, and here as y. Okay, y. Let me run it. Okay, I'm getting an answer. So here what error we got is, it's asking a 2D array, and we have given it as one dimension, okay, which is this. So what I will do is, I'll get back here. I'll write df.drop in single quote price, comma access equal to column. So what this thing is doing is, it is doing the same thing, but it will create a 2D array over here. Let me run it and show you. This columns. Let me run it. So this is creating a 2D object over here. Okay. What we are doing is, we had a table over here, right? df. Okay, we are just dropping this price column. This price column will be dropping and will just retain the area. Okay, and now let me train. Let me get back over here and let me rerun it. So here the linear regression model has completed the training. Okay. Now let me start the predictions, and let me show you the table which it was over here, and let me predict the price for 3300 area. What will be the price? If I run regret dot predict 3300, it will give me the value over here, that is 62,000. Okay, 628715. So here it has drawn a line, linear regression line, which will predict me this thing, the area. If I give the area, it will predict the price. And let me give some other value over here. I will give it as 300. It will give me this. Let me give the same value. Let me give this 4000. Let me see if it is predicting the same thing or what. And let me run it. has given me 72377. So this is due to the error, okay, which I told you in this, the errors. And now let me print out the coefficients. As I told you, there is the expression which is y is equal to mx plus c. So this is the coefficient and the intercept. This is the equation. So you can give whatever the value of x, you will get the whatever the value of x which we had given as 3300, we will get the predicted value of y. Okay, this is the linear regression model for a single variable, single dependent variable. Here we had just the area. Based on the area, we are predicting the price. But there are multiple parameters as well. Like we need to have a look at the area, the location, and we'll also have a look at the storage, how many storage building it is, and how many house, 2 BHK, 3 BHK, and we need to consider all those factors over here. So for that, we'll have a multiple variable linear regression model, which we will have a look in our next video. So thank you. I hope you understood this. You will get the link for the code in the description below.